Previously, we have seen that when objects collide in one dimension, then the focus of laws ataupun calculation based would be using either conservation of momentum if it's elastic and elastic, both inelastic and elastic, and as well if it's elastic, then we have another expression which is in the simplified version kinetic energy, U1 minus U2 equivalent to V2 minus V1. However, the technique would be slightly different when it comes to two dimension. How different? Okay, we need to treat conservation of momentum into their components. This is number one. Number two, the energy, conservation of the kinetic energy, provided that the system is elastic. We're not going to use the simplified version. In fact, we are going to use the full version. Why? Because or else you get stuck with the angle. Nanti ada banyak trigonometry identity. Example 9.8, collision at an intersection. What to expect of this example is that the situation is perfectly inelastic. Hence, our calculation would purely come from conservation of momentum. Okay, how do we know? Because one of the terms or description for the situation, it sticks after the collision. Right, we have two cars here, 1500 traveling to the east. So this is the one. With the speed of 25 collides. Okay, speed because according to the figure, it's traveling to the right. So we need to consider the direction in the x direction. Then it collide with a truck that in the direction of north. So this is y direction with the speed of 20. Okay, now you need to find direction, magnitudes of the final velocity, provided that the vehicles will stick together at the end of the collision. So since this is an isolated case, or perhaps it should provide terms such as by ignoring energy loss, calculate the direction and magnitudes of velocity. Right. Then quite clear that is an isolated system. Right, looking at the situation in the x direction, it's quite clear from the very beginning, it's solely from the car. Therefore, this expression would become 1500 times positive 25. Okay, now what about after the collision? Since they tangle, melekat, then the mass we can factorize. So mass become 1500 plus 2500 with an unknown's value of v, and including that the same angle. So we can look in the scenario that there is just one value of v traveling in such direction, and there is this single unknown angle only. Lagi senanglah kerja kita. Now what about in the y direction? So look closely in the figure of the car. It's in the x direction and the truck is in the y direction. So that's the reason why you find that in the truck, okay, it was 2500 plus times 20, because this is in the direction of positive y. Now how about on the right expression? So same as the above, 1500 plus 2500, and everything should be timed with assigned product of theta unknown. Now, from here onwards, you have two expression. Observe something from this expression. You have number one, no value of theta. Number two, no value of V final. So from these two, you need to combine that two expression and arrive with the answer. In this case here, the technique used is by dividing. So you can choose by this method because one of the trigo quantities identity that we learn is sine divided by cos turns into tan. Okay, and arriving with this answer. Give it a try in order to get V final and the direction where the direction is in the form of angle. Example 9.9, you are going to see the effect of collision in two dimension when you have proton hits with proton. Okay, so there would be a use of conservation of momentum and also conservation of kinetic energy. Now, however, you will find that there are three unknowns in this scenario. Number one, the velocity of each proton. So we're going to say V1, V2. And finally, the angle. Since there are three unknowns here, you will end with three simultaneous expressions. Since the understanding is, or the technique used when we have three expression would be a little bit tough, hence I would purely use this example to come up with number one, conservation of kinetic energy, and from conservation of momentum, another two more expressions. So our aim of this example is to come up with the expression, but not yet solving it. Okay, let's look at what's given. So you have a single proton move, hit elastically with another proton. So the speed is 0. If the incoming proton has a initial speed of 3.5 to the power of 5 to the power time 10 to the power of 5 meter per second, it hits similar as in figure 9.12. At close separation, the proton exert repulsive electrostatic force. We are going to neglect this concept. We are going to say that as if there is no other forces except that when they collide. Okay. Alright, now after the collision, one move at an angle. So given angle. And yet the second one is deflected at an angle of psi. So find the final speeds of the two protons. So we have two unknowns here. Speed V1, V2, and finally the angle. So all of them three unknowns. So we find that the scenario, this is the initial or the incoming or the original direction of U, and then after the collision we find that it's deflected at number one at 37 degree and the other angle is unknown. So we are going to use conservation of momentum in the X component and in the Y components, two expression, and this one, the conservation of kinetic energy. Now, in the X direction, conservation of momentum, we are going to see that the single momentum come purely from one proton just now. So, it should be written as such, m times 3.5 to the power of 5, the initial speed just now. And because it's traveling in the positive X direction, it's by positive value. Add up in the X direction, mv cos theta plus m2 cos psi. However, you should notice that in the calculation is that we have the same mass. How do we know it? Because it's the same proton. So you can now cancel out the mass. And when you cancel out the mass, you have the expression as number 1. Now let's look at number 2. Number 2 is conservation of momentum, however, for the direction of y. So initially, according to the figure, there is no velocity, so that's why it's 0. And then open up, okay, both component, you will find that v2 is in the negative direction, pointed downwards. Okay, so leaving the expression as this one. And same with the mass, since they have the same mass, we can simplify and cancel them, and becoming as number 2 just now. Okay, for the third expression, it will come from kinetic energy, which half mu squared plus half mu squared as such. So again, the same concept occurred. They are of the same mass, so you can now cancel off all the mass. And number 2, they are having the same constant, 1 over 2. So as well cancel away the 1 over 2, leaving your expression as u squared equivalent to v1 squared plus v2 squared, where it will look something like this. Alright, for this example, my aim is purely to produce the expression based on the understanding of elastic collision. So that's it. Okay. We are going to turn to another example which is much simpler. So stay tuned. Now turn to the problem at the end of the topic. Look at question number 23. So we are going to use these simpler questions and plug in all the concept regarding glancing and as well elastic situation. So the situation is still about having a proton. It has initial velocity as vi, and then happen to hit or collide elastically with another proton that is at rest. Now, provided that, or assuming that they have the same equal value of v after the collision, find speed of each proton, v final of each one, and the direction of the velocity vectors after the collision. Now, in the first scenario where conservation of momentum for x component, notice that we have m times u. Okay, this is the u, because I direction I had represent in the x direction. So equivalent to the product of mv cos theta plus mv cos phi. Alright, and that goes the same in the y direction, similar to the example earlier where there is no movement, no momentum in the y direction initially, and therefore mass v sin theta plus mv sin phi. Now this expression can now be simplified since they have the same mass, so you can cancel off the mass and turn to this expression. u1 is v cos theta plus v cos psi. Now in the y direction, same happening, so we can simplify. However, notice that when we rearrange the expression, okay, we can cancel off the v. Why? Because they have equal speed, and therefore we arrive with that sin negative sine theta is sin psi. So this only if we check with angle, only if the angle is 45 and negative 45, like this one, or either way, the other way around. Okay, maybe theta is now for positive 45, psi is negative 45. It could be the other way around, swap. In the conservation of kinetic energy, so this is how it looks like. Initially, there is only one kinetic energy coming from the moving proton, so half mv squared. And then finally, they have the same speed, so both, it will look something like this. And again, since proton has the same mass, so kita tak tunjuk lah. Another way to know why proton, or perhaps just an indicator that proton has the same mass, go at the back of your calculator, dekat belakang tu ada value constant belonging to mass of proton. So therefore mass of the proton is the same. So when you cancel off mass, you can as well simplify by cancelling product of half. So leaving your answer as U1 squared just now, equivalent to V squared plus V squared. Now notice that since they are the same, so you can now add them up becoming 2V squared. Okay, now from here, we are going to rearrange. Kita susun, kita dapatkan V, yang ini V, equivalent to U1 squared over 2. Jadi kita pemudahkan lagi, U1 now tinggal U saja, U1 saja, U squared kan, square root kan. So leaving it as such. So what to do next? We are going to substitute the product of U1 from the first expression in the x component. Okay, now U1 is 2V cos theta. How do we arrive here? Notice that the two angle is actually the same. So product of cos theta and cos 45 is actually similar value. And therefore we can factorize it. So becoming 2V cos theta, or you might even like to write it as 2V cos psi. It's the same thing. Okay. Now, those who are still confused, okay, remember just now that both V are pointed in such direction. So when we open to x component, both are in the same directions. Okay, and here we find that the angle is the same, so that's the reason why they are of the same thing or can be factorized. So this is the answer. This is the answer. This is the answer we are looking for. Give it a try. Our last concept to learn in chapter number 9 is center of mass. For this portion, there will be no calculation involved. In fact, the idea that we're going to understand is to prepare you for the next topic, which is about rotation. Now, in the case of what is the center of mass itself, the key words here is the average position. I love this understanding, but we are going to take only partial of it. What is, if you were asked, what is center of mass? Okay, is one location, one position, one point where all the mass appear to be concentrated. Look at this word. The body, the full body, cannot be supported by placing a single force at the beak, meaning holding it at the beak itself. So in short, the whole mass is concentrated at the beak. Now, to make things simplified, you will find that our discussion from here onwards in the next topic, that center of gravity is the center of mass as well, to make it simple. And also,